In this video, we are going to study about the derivative of the parametric function. For the parametric function x and y, there are two different functions that depends to different parameters. This parameter here, it is equal to t, and with respect to t, we are finding two different functions like it is given in the exercise. Let's say x is equal to t plus 2 and y is equal to 2t squared minus 1. So these are parametric functions with respect to t. We can change this parameter, but generally we are using t for the parametric functions. Okay, what is the derivative of this expression? It says find the derivative of parametric functions with respect to x, which means dy over dx they are asking, and we are finding the derivative of t firstly with respect to y derivative with respect to t, and we are finding the derivative of x with respect to t again. And here the variable, when you get the derivative of the t, the variable becomes t. So if I ask this question to you, y is equal to x plus 2, or y is equal to 2x squared minus 1. If I ask this question to you, you are going to tell me that the y derivative, when you get the y derivative, it's equal to 4x minus 0 actually, but it is not written. You are going to tell me that y derivative is equal to 4x. So the derivative of y with respect to t, the variable is t here, it's going to be same. So if I need to find dy over dx, I have to find dy over dt and dx over dt, and this means that 2t squared minus 1 derivative with respect to t, you should think t as x. In the previous questions we were solving with respect to x. That's why in parametric function t becomes x somehow. We can say like that, t plus 2 derivative. So 2t squared, it's going to be equal to 4t. I should try to explain here how the x value is equal to, y is equal to 2x squared minus 1. Here 2t squared minus 1, the derivative of it's equal to 4x, so derivative of this expression, it should be 4t, and derivative of t is equal to 1, derivative of 2 is equal to 0, so this is going to be equal to 1. The answer is going to be equal to 4t. In another word, we can say also like this is y derivative, and y derivative is equal to 4t, but generally for parametric functions we are using dy over dx, because when you get the derivative of this expression, it becomes also y derivative. That's why not to confuse that one, or not to mix with that one. Okay, now we have one known equation here. X is equal to 8 times cosine t and y is equal to 8 times sine t, which means dy over dx is equal to dy over dt over dx over dt. It's going to be like, there is a simplifying here. We are going to think, we may think like that, and we will easily memorize that one. We are going to simplify and we are going to find dy over dx, but actually it is not simplifying operation. It is equal to 8 times sine t derivative over 8 times cosine t derivative is going to be. A is the coefficient, so when we are getting the derivative of the expression, the coefficients are not important, so we are going to leave same. A times cosine t, for the sine derivative it's going to be equal to sine t derivative is going to be cosine t, and cosine t derivative is going to be equal to minus sine t, so it's equal to minus 8 times sine t is going to be cosine t over sine t. A and a you are going to simplify and you are going to have minus 1. Cosine t over sine t, it's going to be equal to cotangent t, so cotangent t, the answer is going to be equal to minus cotangent t. Okay, and the next one here, find the slope at x is equal to 2 also, it says. Here there's the important part. X value is equal to 2. If x is equal to 2, t should be something different. What it should be? Let me find firstly that one. And first let me get the derivative of these expressions. And dy over dx, they are asking when x is equal to 2. What is the value of it? And first I'm going to get dy over dx. dy over dx is equal to dy over dt over dx over dt. It should be firstly. Then this is the derivative t squared plus 3t, 3 squared plus 3t derivative over root of, or we can do like this, t plus 1 to the power of 1 over 2, because root means the power of 1 over 2. Derivative is going to be, and that's going to be equal to derivative of t squared is equal to 2t, derivative of 3t is equal to 3 is going to be, but for the denominator we don't have that derivative directly because we have the power. If we have the power, f to the power of n x derivative by using the chain rule, how it is n times fx fn minus 1 x times f derivative x, it should be same here. 1 over 2, this is the power comes in front, and I should decrease the power, t plus 1, 1 over 2 minus 1, it's going to be 1 over 2 minus 1, then times t plus 1 derivative, it should be t plus 1 derivative, which is equal to 1 is going to be. Then this expression is equal to 2t plus 3 over 1 over 2 t plus 1 to the power of minus 1 over 2, 1 over 2 minus 1, because it's equal to 1 minus 2 over 2, it's going to be, times t plus 1 derivative is equal to, t derivative is equal to 1, plus 1 derivative is equal to 0, so it's going to be equal to 1. And this power sends this expression to the denominator, and it's also 1 over 2. That's why it's going to be equal to 2t over 1 over 2 times root of t plus 1. T plus 1 it's going to be. And the last part, it's going to be equal to 2t times 2, 1 over 2 becomes, this 2 goes also up, to t plus 1 it's going to be. Here I found dy over dx, and now I have to replace the x by 2. But as you see, we don't have any x term here. What we are going to do for this one? Firstly, I have to find what is the value of x in terms of t, which means if x is equal to root of t plus 1, when x is equal to t, 2 becomes root t plus 1, that's equal to 4 is equal to t plus 1. I got the square of both sides, square of this one and square of this one, and these two simplified, and t is equal to 3, which means dy over dx, when it's equal to, when x is equal to 2, is equal to dy over dx when t is equal to 3. This means this is equal to, here the function is 2 times 3 plus, times 2 times root of 3 plus 1, which is equal to 2 times 3 times 2 is equal to 4 times 3, 12. 12 times root of 4, 12 times 2, which is equal to 24, is going to be. And with this question, we are going to find the second derivative of the parametric function. And here the rule it is given. D squared y over dx squared, it's the second derivative with respect to x. but here it says that dy derivative over dx, which is equal to dy derivative over dt over dx over dt. So we are going to get the derivative of the y. We are going to find dy over dx firstly, then we are going to get the derivative of the y with respect to t again, derivative of the expression. Then we are going to divide this one by dx over dt. So firstly, let's get dy over dx for this question, because they are asking d square x d square y over dx square, where x is equal to 1 plus e to the power of t, and y derivative is equal to t square times e to the power of t. It's going to be, then dy over dx is going to be equal to dy over dx is going to be equal to dy over dt over dx over dt. It's going to be, then this is equal to t square times e to the power of t derivative over 1 plus e to the power of t derivative is going to be, so t square times e to the power of t is equal to t square derivative times e to the power of t plus t square times e to the power of t derivative. The derivative of the multiplication is going to be, then it's equal to here this is derivative of 1 is equal to 0, so e to the power of t derivative is going to be, so e to the power of t derivative is equal to e to the power of t. It's going to be 2t times e to the power of t plus t squared times e to the power of t derivative is going to be equal to e to the power of t again, and e to the power of t. E to the power of fx, e to the power of x derivative, if you remember, is the only derivative that is equals to itself. I said here we have the same thing. Here e to the power of 3 and e to the power of t, it's same. E to the power of t, if parentheses, if you get 2t plus t squared over e to the power of t, it's going to be, when you simplify these two, the answer is going to be 2t plus t squared. This is dy over dx, and when I get the derivative of d square y over dx square, I need to get dy over dy derivative over dt over dx over dt, it should be, which is equal to here dy over dy derivative over dx, it should be, and the formula it's written here, which means dy over dt, the y derivative with respect to t, it's going to be equal to, this is y, because y derivative is going to be here, and I have to find 2t plus t square derivative over 1 plus e to the power of t derivative again, and this is going to be d square y over dx square, which is second derivative of the parametric function, and the derivative of this expression is going to be equal to 2 plus 2t over 1 plus e to the power of t derivative. Here I have here, that's why the answer e to the power of t. This is going to be the end for the question. Okay, the next question. Here firstly I have to find the dy over dx. dy over dx is going to be equal to dy over dt over dx over dt is going to be, and it's going to be equal to here dy over dt, the derivative of y1 minus t cube derivative over 2t minus t square derivative it's going to be, and derivative of this expression, derivative of 1 is equal to 0, derivative of minus 3t cube is equal to minus 3t square, minus 3t square over derivative of 2t is equal to 2, derivative of 3 square is equal to 2t, and minus, we have here minus 2t, it must be. Okay, we found the first derivative of the expression. At the end, this is equal to y derivative. And for the second derivative, dy over dx, dy square over dx square, it's going to be equal to dy derivative over dt over dx over dt. It must be, which is equal to minus 3t square minus 3t square over minus 2t derivative over 2t minus t square derivative is going to be. And derivative of this expression, you know, f over g derivative we have here, because this division's derivative, which is equal to f derivative times g minus f times g derivative over g square. It must be, which is equal to minus sign, it's going to be in front of it, 3t square derivative times 2 minus 2t minus 3t square times 2 minus 2t derivative over 2 minus 2t square. It must be. Here the derivative, pardon, the down, it's going to be 2t minus 2 minus 2t. It's going to be derivative of 2t, it's equal to 2, and derivative of minus t square is equal to minus 2t. It's going to be. Here the denominators are same, here the smaller one and the bigger one. Here it should be actually like this, and this denominator may come down, which is equal to here minus sign, it should be also here, 3t square derivative is equal to 6t times 2 minus 2t minus 3t square, again same here, times minus 2 derivative is equal to 2 derivative is equal to 0, minus 2t derivative is equal to minus 2. It must be. Okay, then it's going to be equal to down 2 minus 2t cube. It should be, this comes down and you're going to multiply this one, the powers 1 and 2, we add the powers, that's 3. Okay, 6t times 2, it's equal to 12t minus 6t square. Here minus 3t square times minus 2 plus 6t square, it's going to be over 2 minus 2t cube. It's going to be this 2. When you simplify the answer, it's going to be equal to 12t over 2 minus 2t cube is going to be